right? And now next move that we would like to go for understanding a variable register. What is a variable register? A variable register is we call potentiometer, which is got maybe three terminals, and this is what is called a variable register. Okay, this is a variable register. It has got 1 point, 1 point, and 1 point. Typically they are round in shape when you look it in the physical way, but when we represent it in a circuit way, it is given like this. Okay, now what I do now, okay, let me disconnect this connection, disconnect this connection, and bring it here and put it here, and let it be say my 4K, and let this be what I had gone earlier, let this be 8K. Alright, now what I do is I give the connections what we had done. So I give this connection to here, I give this connection to here, and I give this connection to here. Now let me see how the voltage is behaving in a voltage divider situation. I know if this is 12 volt and this is 8K and this is 4K, that means at this point the voltage will be 4 volts. At this point the voltage will be 0 volts, right? So let's see, and at this exactly at 50% the voltage will be half the voltage of 4 volts, because the total voltage drop across this is 4 volts. So this will be half the voltage. Now let's see, while we power it, I get exactly 2 volts here. Now if I go on going up, I see the voltage is going up. Now here it comes to 4 volt. When it comes here, it is 4 volt, or when it goes down, it goes to 0 volt. So this is how a variable resistor can be used for getting variable voltage as per our requirement. Sometimes we require such kind of arrangement where a particular voltage needs to be given to certain circuit. So that is how the potential divider comes into real picture. Now next, after understanding the potential divider, let's see that how we use sometimes a variable resistor in a little different fashion. Like for example, I delete this, and what I do is, okay, I take this connection and give it here, and give it say here. Now let me see what exactly the situation here. Now this resistance is 8K, but this 4K resistance is now half of it is bypassed. You can see half of it is bypassed. That means the virtual resistance of this, the actual resistance of this is about 2K. That is from here to here, because here to here it is bypassed. So it's a 2K resistance. That means 8K and 2K. In that ratio it will come. That ratio means 8K, 2K. This is about how many times? 2K is about 6 times. So how much voltage will I get? I get 2.4 volts. And when I change it this side, the voltage goes on falling and ultimately goes to 0. That means I am able to vary it from 0 to 2.4 volts. And if I go on above, and then I get 4 volts. This is also another arrangement where I can vary the voltage in this fashion, right? So this is how the potential divider or a variable resistor can be used for specific requirement of voltage. Now, having seen all this, let's go over to some very simple circuits that we will be using in our projects. Now let us remove all this. Let's have the meter only, and let me take a transistor. Now let's say if I take a transistor here, this is a transistor, and then let me connect this. Okay, sorry, we go to a LED again. Okay, let's connect an LED here. I connect an LED here, and I connect a series resistor. As I have always said that the resistance is a must in case of any LED that I am going to use. So I put a resistance here, and this goes to ground, and this is, supposing I put one more resistor here, and I put it in a way that I should be able to connect it. I put it this way, give it a connection here, and give it a connection here. Now let us zoom it so that all of you can see it better. Oh, not coming. Okay, so I take it this way. Sorry. Right, now it's visible. Okay, now let me analyze this circuit. Now, okay, connect the voltmeter also here. We'll see what is happening when this is powered. Okay, now when I power this, I know there is a leak. There is absolutely 0 volt here, and then when we switch on this, what happens? That this LED glows this way. How? Transistors, in most of the cases, what we will be using in our projects are used as switches. Transistors have got several other features, but in all our projects, most of our projects will be using transistor as a switch. Let's understand how this works. Now when I apply the power, the first current flows this way, 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 this way. That means the base to emitter, the current flows. This is an NPN transistor, and in an NPN transistor the current has to flow from base to emitter for the collector to emitter to get switched on like a switch. So what happens? So when the current flows this way, this way, this way, this way, this way, this way, and this way, and this, then only this current starts flowing this way, this way, this way, this way, and this. And once the current starts flowing between this is, as I said, these 2 points are just like a switch. Just like a switch means once the switch closes, the voltage drop across this is nearing 0. Just the switch drop, or the saturation voltage drop we call it. And so since this particular point comes to ground, because this particular point comes to ground, it is nearly 0 volts. So this is what a transistor is used like a switch. Now let's understand a little more about it. That means when this current is flowing between base to emitter, then only the current will flow from collector to emitter in the direction of the arrow. That means this current will flow this way, and this current will flow this way, right? This current will flow this way, and this current will flow this way. So this is what the way that the transistor is operating on a switching function. Now when this current flows from here to here, when this side is high and this being low, low means negative. So when this is high, then only the current flows. So, and at that situation, this point becomes low. That means since this point comes to ground, so this becomes low. That means when base is high, that means when this point is high, this point is low, and when this point is low, this point will be high. We can see that. Now supposing I do not pass the current through the gate, through the base. Now let's see. You see, if I do not pass current through the base, there is no current flowing. There is no current flowing here, nor no current is flowing here. So what is happening? I am getting the full voltage here. That means this is the open circuit voltage, or I call it high. So when now this is low, low means there is no current flowing here. So this is low. So when this is low, this is high, and when this is high, this is low. That's what we have seen. Now we will connect it again. Okay, I connect it again and see what is happening. See, now this current flows this way, and this current flows this way, and that is how the switching function of a transistor is achieved. In most of your projects, will be handling switching functions like this.